Hello there and welcome back to the Sleep Science. You find yourself on a warm summer morning in 1977, standing just beyond the scorched concrete of Launch Complex 41 at Cape Canaveral. There's a faint tang of jet fuel in the air, mixed with sunscreen and anticipation. The crowd around you buzzes in low murmurs, heads tilted skyward, as a pillar of fire lifts slowly, then suddenly surges. Voyager 2, not the first to launch but the first on the schedule. It rises like a promise wrapped in metal, disappearing through humid clouds that will never see it again. It's going to places no human will likely ever visit. And soon, just weeks later, Voyager 1 will follow, launched second but destined to overtake its sibling in speed and distance. Because, well, rocket math is weird like that. You watch the plume stretch and thin, and there's a brief moment of silence, the kind that only happens after the ground stops shaking. You're staring at a machine that may still be working long after you aren't. And here's the thing, no one's entirely sure this mission will work. It's aiming for a cosmic trickshot, swing past 4 planets, gather data, and survive deep space for, optimistically, 5 years. Spoiler alert, you're already 40+ years into overtime. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, drop your location and local time in the comments. I love seeing where you're watching from. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The control room is tense. Coffee's gone cold. Someone's chewing their pen in a very NASA kind of way. Over the speakers, telemetry chirps like distant birdsong, those comforting beeps of a spacecraft that's still talking. At this point, you're more than just an observer. You can feel the engineer's nerves. You hear the crackle of vintage headsets. These 2 spacecraft, Voyager 1 and 2, are riding Atlas Centaur rockets and are almost absurdly analog. Their memory capacity is less than your smartwatch. Their computing power wouldn't impress a toaster, but they're brilliantly designed, modular, redundant, and filled with instruments that seem more magical than mechanical. This isn't the space shuttle. This isn't Apollo. These Voyagers are quieter, lonelier, and built to never return. They don't splash down, they don't bring back rocks, they leave forever. And somehow that makes them more human. You think back to the mid-1970s when this all began, when a group of nerdy optimists at NASA's Jet Propulsion Lab realized something big. A rare alignment of the outer planets, Jupiter, Saturn, Uranus, Neptune, was coming up in the late 70s. A perfect orbital geometry that happens only once every 176 years. Use the gravity of each planet to slingshot to the next, saving fuel and extending range. The idea, launch one spacecraft that could visit all 4. NASA loved the concept but couldn't afford to fully commit. Instead, they greenlit a Jupiter-Saturn-only mission with potential for more. The engineers, being sneaky geniuses, designed the Voyagers anyway to quietly be capable of visiting all 4 gas giants, just in case. Imagine building a car meant to drive across a city but stuffing it with supplies for a transcontinental trip, just on the off chance the highway opens. That's what they did. And they did it without smartphones, cloud computing, or real-time GPS. Just slide rules, chalkboards, and a whole lot of caffeine. You follow Voyager 2 first. It launches on August 20, 1977. A solid burn, a smooth deployment, and off it goes on the slow but steady path toward Jupiter. Just 16 days later, Voyager 1 takes off, faster, more direct. It'll reach Jupiter first, even though it launched second. It's like 2 paper airplanes launched from a staircase, one loopier, one sleeker, each with its own destiny. You can almost imagine them waving goodbye to Florida, their solar panels catching a bit of sunlight that will grow dimmer with every mile. Here's a weird tidbit. The spacecraft weren't even originally called Voyager. In the early days, NASA briefly considered naming them Mariner Jupiter Saturn 1977. Catchy, right? They were part of the Mariner family of spacecraft. But eventually, someone in a naming meeting must have looked at those curvy planet-hopping trajectories and said, "It's stuck." Historians still argue whether this mission was a triumph of planning or a miracle of improvisation. The timelines were tight, the budgets were tighter, and the ambitions, frankly, bananas. But now you're watching Voyager 1 settle into its cruise phase, leaving Earth behind at over 38,000 miles per hour. No brakes, no pit stops, just endless momentum. There's something quieting about that. The idea that these twin robots, little more than interplanetary message bottles, are hurtling through space with no way to turn around, no emergency reset button, and only the faint hope that, years down the line, someone on Earth will still be listening. And just to keep things deliciously retro, each spacecraft carries a small plaque that reads a gift from the people of the planet Earth. It's not quite a postcard, more like a cosmic whisper, a sigh across the stars. Back in the present, you lean against the safety rail and feel a flicker of awe as the final booster stage falls away. The Voyagers are free now, no longer bound by Earth's gravity, no longer ours, really. And just think, this is only the beginning. They haven't even seen Jupiter yet. You ride the silence of space now, a steady hum beneath your thoughts as Voyager 2 drifts further from the warmth of the sun, its path laid out like a cosmic game of hopscotch. Only the stakes are much higher, and there's no playground, just billions of miles of darkness. What makes this all possible isn't just determination or funding or guts, it's timing. You're catching the solar system in a rare moment of planetary choreography, a lineup that only graces our skis once every 176 years. You couldn't wait for the next one unless you plan to live until the year 2153. Spoiler, you won't. Back in the late 1960s, a 25-year-old NASA engineer named Gary Flandreau ran some numbers, mostly out of curiosity. He noticed that in the late 1970s, Jupiter, Saturn, Uranus, and Neptune would all swing into a favorable formation, perfectly placed to let a spacecraft use gravity to slingshot from one to the next, a trick that not only saves fuel but also boosts speed. Think of it like galactic pinball, with each planet giving Voyager a thwack that sends it careening farther outward. This wasn't just a happy coincidence. It was a fleeting doorway, and someone had to crawl through before it closed. So the Grand Tour idea was born, a mission to visit all 4 outer planets with one craft, wildly ambitious, painfully expensive. Congress gave it a suspicious side-eye and said, "Hey, how about just Jupiter and Saturn for now?" Which is like telling someone they can only have half a sundae. But Voyager's engineers, unfazed, quietly packed the whole dessert anyway. They built in extra shielding, extended communication range, and added software flexibility, all under the radar. Should someone someday give the go-ahead to continue on to Uranus and Neptune, the spacecraft would be ready. Meanwhile, the public, barely aware, the headlines were mostly about disco and gas shortages, but a few science columnists tried to explain what a gravitational assist actually meant. Picture throwing a tennis ball past a moving train. If the train's moving fast enough, the ball gains speed. Now, imagine the train is Jupiter, and your ball is a 1-ton spacecraft with an appetite for radiation and moon selfies. The math behind this maneuver is mind-melting, but in practice, it works like magic. When Voyager 1 hits its mark near Jupiter, it will use the planet's immense gravity to bend its path and accelerate towards Saturn. Voyager 2 will follow, then veer off toward Uranus and, if everything behaves, Neptune. Of course, behavior in deep space is never guaranteed. Historians still argue whether NASA's bold commitment to slingshot mechanics was a stroke of genius or just a brilliant bluff. If any planetary alignment had shifted even slightly, if the probes missed their windows by just a few days, the whole plan could have collapsed like a souffle in a thunderstorm. You float in the inky blackness now, staring at the chalk line the Voyagers must follow. The distances are staggering. Jupiter is 400 million miles from Earth. Saturn, nearly twice that. Neptune, you don't even want to know. And this isn't a road trip with scenic stops and vending machines. The Voyagers must hit each gravitational assist with surgical precision. There are no second chances. Back in mission control, the team monitors every course correction with white-knuckled intensity. Tiny burns from hydrazine thrusters adjust the trajectory, each maneuver calculated weeks in advance and executed over endless patient hours. The spacecraft don't steer like cars. They drift like whispers on a breeze, nudged gently, then left to coast. You listen in on a planning session. There's a dry erase board with dozens of flight arcs, each drawn in wobbly circles and overlapping loops. Someone's muttering about delta-V budgets. Another is recalculating signal lag, how long it takes for instructions from Earth to reach the Voyagers. Right now, about 40 minutes one way. By the time the spacecraft reach Neptune, it'll be nearly 4 hours round trip, so there's no such thing as real time. You send your commands, you wait, you hope. And here's a fun fringe tidbit. One early plan involved putting cameras on the spacecraft that astronauts could later retrieve, like a celestial GoPro. But then someone remembered, hey, maybe we're not going to Neptune anytime soon, and the idea was quietly shelved. The Voyagers, once launched, aren't flying blind, but close. No one's been out there. No one knows what surprises await. Some worried about micrometeorites or unknown radiation belts. Others fretted that Jupiter's powerful magnetic field might fry the electronics. The team armored up the sensitive parts, crossed their fingers, and added one more item to Voyager's resume: space guinea pig. And yet, even with all this complexity, Voyager's route is remarkably graceful. It's the celestial equivalent of a slow, long pirouette, one that will eventually carry it beyond the influence of the sun itself. But that's years from now. For now, you're focused on the next big milestone, Jupiter. But before you get there, you pass through the asteroid belt, a cluttered mess in theory, but in practice surprisingly sparse. Hollywood lied to you about that one. There's no dramatic weaving through tumbling boulders, just a slow glide past hunks of rock, most no bigger than a small mountain. Still, the risk is real. Even a pebble traveling at tens of thousands of miles per hour could be a death blow. The team holds its collective breath. Voyager 2 emerges unscathed. So does Voyager 1. The grand tour continues. Back on Earth, barely anyone notices. A few newspaper clippings, a blip on the evening news. But you astride this invisible spacecraft, swept forward by gravity and engineering, you can feel the tension tightening. The real show is about to begin. You drift now within the sterile calm of a cleanroom in 1976, surrounded by white suits, filtered air, and the faint smell of ionized metal. Here, beneath banks of humming fluorescent lights, two skeletal spacecraft lie on their sides like sleeping insects, Voyager 1 and Voyager 2, nearly identical twins with a lifetime of exile ahead of them. There's something oddly tender about their construction. Engineers bend over them with the reverence of watchmakers, adjusting magnetometers, wiring thermal blankets, tightening golden bolts on equipment they'll never touch again. The Voyagers aren't just built to fly. They're built to last. And in the unforgiving deep freeze of space, lasting means surviving radiation storms, solar winds, and total isolation for decades, without a single oil change. The shell is aluminum, the inside's a symphony of circuit boards and scientific ambition. Each component is weighed, tested, and tested again. Instruments include cameras, spectrometers, plasma detectors, and cosmic ray sensors. And because they must all run on precious trickles of power, each system has a purpose and an expiration. You watch as someone carefully installs the radioisotope thermoelectric generators, RTGs, on the side of the craft. They're squat, finned cylinders filled with plutonium-238, decaying steadily, giving off heat that can be converted into electricity. It's a quiet power source, one that hums in milliwatts and promises years of service. Hopefully. Even the computer system is endearingly modest. The Voyagers each have 3 main computers, and none of them would pass muster in a modern toaster. You, reading this, are thousands of times more powerful than the twin spacecraft combined. But unlike your laptop, these machines are radiation-hardened, built to reboot themselves, and most importantly, built to obey. They receive commands transmitted from Earth and respond without ego or error, just beeps, bursts, and bites. And let's talk about those commands. Voyager doesn't just take direction, it needs direction constantly. There's no AI on board, no clever autopilot. Everything must be pre-written, encoded, and sent across millions of miles with the expectation that the spacecraft will interpret it perfectly. And once the signal goes out, you wait. Sometimes for hours, sometimes for days. You've got one shot. The Deep Space Network handles this, an array of enormous radio dishes scattered around the world in California, Spain, and Australia. Their job: catch the whisper of Voyager's voice across the void. At launch, the signal is strong, almost chatty. But as the craft gets farther, that voice dims like a walkie-talkie drifting out of range. Even in 1977, NASA was already planning how to listen harder, designing more sensitive receivers, amplifiers, and data compression tools, just to keep the conversation alive as the Voyagers went mute to all but the most devoted ears. Back in the clean room, one engineer grins as he attaches a high-gain antenna, Voyager's literal voice box, a parabolic dish over 12 feet across. Sleek and white, it gives the spacecraft a kind of insectoid elegance, like a dragonfly that talks to planets. It's built to focus energy tightly, like a flashlight in a cave. Without it, Voyager couldn't be heard. With it, it might one day send back images of worlds no one has ever seen up close. Now for the quirky bit. At one point during design, engineers debated how to protect the sensitive optics of Voyager's imaging system. The lens cap problem. If you're going to build a billion-dollar robot photographer, you don't want its first pictures ruined by dust or light leaks. So what did they do? They fashioned a little cover held in place by string and a pin, released by a small explosive charge, basically a glorified party popper. Low-tech, maybe. Effective, absolutely. One sharp pop in space, and the lens was clear. You sit with the builders during their coffee breaks. Some are young, barely out of grad school. Others have gray at the temples and stories of Apollo or Mariner days. They argue about trajectory math, swap stories about malfunctioning gyros, and occasionally pause to gaze at the spacecrafts like proud but nervous parents. They know that once the Voyagers are out there, no one can catch them. No repairs, no updates. They'll either work or they won't. This is it. The final touches are ceremonial. Each spacecraft gets a few markings, some final wipe-downs, and the fabled golden record, though we'll get to that treasure in a later section. For now, you watch a technician slip the record into its holder like a priest placing a relic into a tabernacle. It glints under the fluorescence, a message in a bottle for the cosmos, just in case someone or something out there ever picks it up. Historians still argue whether this cleanroom craftsmanship marks the peak of practical engineering or the start of our obsession with robotic exploration. The Voyagers were designed without ego, without branding, without corporate logos or product placements. Just machines built to witness, built to endure. And endure they would. Each component is double-checked, then triple-checked. The spacecraft are moved out, placed gently on their sides in transport containers, and wheeled toward the launch pad like royalty in waiting. No one speaks above a whisper. There's too much riding on every bolt, every circuit, every nanowatt. As you glide above them, you notice something quiet but profound. These are not flashy machines. They don't gleam like sports cars or thunder like rockets. They are humble, calm, and almost shy in appearance. But that modest frame houses one of the most ambitious human dreams ever forged. The dream to reach out, not just to nearby worlds, but to the edge of the solar system, to interstellar space, to the unknown. Soon they'll be sealed in fairings, hoisted atop Atlas Centaur rockets and pointed at the sky. Soon, the countdown will begin. But for now they rest, silent, ready. The rockets roar, but you're already far past that. The Earth is just a memory now, shrinking behind you like a house seen from an airplane window. Voyager 2 is on its long, slow loop toward Jupiter, while Voyager 1 shoots ahead, the faster of the two, even though it launched second. And here you are, coasting alongside them, slipping effortlessly past Mars, ignoring Venus entirely. A bold departure from the previous missions. Mariner, Pioneer, even Viking, they all paid Venus a visit, poked around the cloudy inferno. But Voyager, nope. No time for detours. Venus got ghosted. It wasn't personal. Venus just wasn't part of the grand tour geometry. The real prize lay further out in the realm of giants. Jupiter, Saturn, Uranus, Neptune, those massive orbs with their rings and storms and strange, icy moons. That's where the mystery lived. And with such a rare planetary alignment, there wasn't room to dally. Every flyby was a countdown. Miss one slingshot and the rest of the tour collapses like cosmic Jenga. So the Voyagers skipped the inner planets entirely, like a speed reader jumping straight to the juicy part of a novel. You travel now through the cold silence between Mars and Jupiter. There's not much out here, some cosmic dust, the occasional rock, and long stretches of nothing. You're heading toward the solar system's bouncer, Jupiter, the largest and arguably most unwelcoming of the planets. Twice as massive as all the others combined, it's a gas giant wrapped in radiation, storms, and secrets. And Voyager is going to get very close. But first, a bit of housekeeping. The spacecraft is waking up, gradually, deliberately. Instruments that have been dormant since launch are coming online, their software booting like a very old computer. Cameras click open. Magnetometers stretch out on long booms like sleepy spiders. Plasma detectors yawn and start listening. Everything's moving according to plan, mostly. Here's the thing about spacecraft. They're stubborn. Voyager, though elegant, is no exception. Commands sometimes get garbled. Systems refuse to respond. At one point, engineers notice that Voyager 1's attitude control isn't behaving. Its thrusters aren't firing quite right, like a slightly drunk ballet dancer missing her cues. The team on Earth scrambles to troubleshoot, rewriting lines of code in Fortran, sending updates over radio waves that take hours to arrive. You can imagine them holding their breath again, but Voyager rights itself. The dance resumes. You can feel the growing tension as Jupiter looms ahead. This isn't just the first planetary flyby. It's the first real test of everything. If the instruments work, if the photos come through, if the spacecraft survives the radiation belts, then maybe the rest of the tour can go forward. But nothing's guaranteed. The pioneers that went before Voyager, Pioneer 10 and 11, gave tantalizing glimpses of Jupiter, but they were fast and blind compared to what's coming. Voyager's cameras are better, its sensors more precise. It's not just passing by Jupiter, it's going to study it. And oh, there's so much to study. You skim your way toward the Jovian system, where Jupiter's gravity starts to pull, to tug, to grab you just a little harder. It's massive enough to affect your trajectory long before you arrive. Even now, its magnetosphere is starting to register on the sensors. It's absurdly large, stretching over 3 million miles from tip to tip. Imagine a magnetic field the size of the Sun, centered on a planet made mostly of hydrogen and helium. It's not just big, it's alive. And it's dangerous. You remember the stories from Pioneer 10, how it barely made it through the radiation without frying its circuits. Voyager is better armored but not invincible. As you drift closer, you can feel the spacecraft begin to tense. The data starts pouring in, and it's overwhelming. Swirling magnetic fields, strange bursts of plasma, mysterious radio emissions that crackle like alien speech. Historians still argue whether Jupiter's electromagnetic voice was the most unsettling thing Voyager ever heard. To some, it sounded like screaming. But you're not scared. You're fascinated. The spacecraft is doing its job, sending back images and measurements at a furious pace. You can almost hear the clicking of shutters, the whirring of tape recorders, the hum of computation. Every byte of data is priceless. And yet, while everyone expected Jupiter itself to steal the spotlight, it's the moons that begin to dazzle. Io, with its violent sulfur volcanoes, erupting in colorful plumes hundreds of miles high. Europa, cracked like glass over an ocean of possibility. Ganymede, bigger than Mercury and laced with grooves like a vinyl record. And Callisto, ancient and pockmarked, a cratered fossil drifting in eternal orbit. Voyager wasn't even supposed to study the moons in such detail. But once the first images came back, priorities changed. The moons weren't just satellites, they were worlds. Alien, dynamic, and weirdly beautiful. And here's a fringe tidbit for you. Some early predictions thought Jupiter's moons might be geologically dead, just cold rocks. But when Voyager beamed back images of Io's active volcanoes, actual volcanoes erupting in real time, scientists gasped. No one expected that. It was the first time we saw active geology beyond Earth, and it changed everything. The spacecraft swoops through the Jovian system with the grace of a practiced tourist, snapping photos, measuring fields, and dodging invisible hazards. It's exhilarating, it's exhausting, and it's not done yet. Soon, the gravity assist will begin, the first planetary slingshot. Voyager will dip into Jupiter's immense gravitational well, then get flung outward with a speed boost that would make any Formula One car blush. It's not just an escape, it's a launch. A new trajectory, set not by thrusters but by physics itself. And then just like that, Jupiter will shrink behind you. The storms will fade. The radio noise will quiet. The spacecraft will continue on past the gas giant's edge toward the next great ring destination, Saturn. But we're not quite there yet. Jupiter is now a swirling memory in Voyager's rearview mirror, but not one you'll forget anytime soon. The gas giant loomed like a painted god, massive and endlessly restless, its storms boiling in amber, cream, and rust. You watched the great red spot churn, a vortex so large it could swallow 3 Earths, its boundaries shifting like oil on water. Voyager didn't just pass by. It lingered, orbited briefly in a gentle arc, soaking in data, capturing the hidden language of a planet that doesn't know you exist. But even Jupiter, in all its theatrical grandeur, was just Act 1. As you sail onward, you're still vibrating from the chaos of the Jovian system. The moons left a mark on you, especially Io, that sulfurous little mischief maker. Before Voyager got there, everyone assumed moons were frozen, geologically dull leftovers. But Io shattered that idea with a volcanic eruption that practically photobombed Voyager's camera. The craft caught it purely by accident, a ghostly yellow plume rising above the moon's limb like steam off a devil's kettle. Suddenly, it wasn't just a moon. It was a living world, and a wildly unstable one at that. You remember the scientists scrambling back on Earth when the images came in. They thought it was a glitch at first, a shadow or artifact. But no, Io was spewing molten sulfur into space, painting its own atmosphere in streaks of lava and gas. Historians still argue whether this discovery or the later oceans of Europa was the most important moon moment. Either way, the solar system suddenly felt a lot less dead. And then there was Europa, the quiet enigma. Voyager's cameras revealed its surface like cracked glass, intersecting ridges and fault lines that looked eerily like Earth's polar ice sheets. No craters, no mountains, no ancient scars. Just smooth, fractured terrain suggesting something active beneath the surface. Water, perhaps. An ocean, maybe. Your imagination surges. What might be swimming beneath those icy crusts? The magnetometer had detected strange readings near Europa, small anomalies that hinted at conductive material below the surface. Saltwater, most likely. An entire ocean, kept warm by the gravitational tug-of-war between Jupiter and its satellites. The idea that a moon so cold could hide a liquid ocean beneath a frozen shell. Well, it rearranged the map of where life might exist. And we haven't even talked about Ganymede yet, the largest moon in the solar system. Larger than Mercury, wrapped in its own magnetic field, scarred by ancient tectonic grooves. Voyager's instruments couldn't fully map it, but what it did see was staggering. Ganymede wasn't a rock. It was a planet in all but name. Callisto, too, though quieter, had its own grave beauty. Heavily cratered, dark, and ancient. Its surface unchanged for billions of years. A cosmic memory card, if you will. Voyager swept past it last, catching a few photos that hinted at something deeper. Layers of ice and possibly, just possibly, more subsurface oceans. You float by it now, marveling at the contradiction. Frozen, silent, and yet alive in some invisible way. As Voyager coasted through Jupiter's magnetosphere, you couldn't ignore the strange side effects. The radiation was intense, like standing too close to a microwave with the door cracked open. Particles bombarded the spacecraft, electron storms that surged and howled. Instruments picked up radio emissions so eerie, so jagged and alien, that some scientists played them through speakers just to experience it viscerally. It sounded like screams or wails or broken violins. And if Jupiter was screaming, what was it screaming at? You almost feel a tremor pass through the spacecraft as it adjusts course, nudging its trajectory just slightly to prepare for the gravity assist. The math was precise, a swing close enough to catch Jupiter's pull, but not so close as to get drawn in. The result? A clean slingshot, flinging Voyager toward Saturn with a boost of over 35,000 miles per hour. No fuel required, just good aim and gravity's free gift. And even as Voyager hurtled away, it was still snapping images, turning its camera back on Jupiter to catch the crescent of the planet from behind. In one photo, you see a shadow play of moon and planet, light curving off gas and cloud. It feels less like science and more like art, a reminder that Voyager is both probe and painter. Now far beyond the Jovian orbit, you ride the silence again. The sun is dimmer now, less a fiery beacon, more a bright star among stars. You can feel the cold growing, the deepening quiet, like diving below the thermocline in an ocean trench. Voyager isn't just heading to Saturn. It's leaving behind the relatively familiar and venturing into stranger seas. Meanwhile, engineers on Earth are poring over terabytes of data. Every pixel, every voltage spike, every unexpected glitch is another breadcrumb on the trail of understanding. Remember, these aren't live feeds. They're delayed transmissions, hours old by the time they arrive. You're not watching history as it happens. You're watching history catch up. A fringe detail that gets overlooked. Each Voyager has a kind of old-school tape recorder on board. That's how data is stored when it can't be immediately transmitted. Magnetic tape, like a mixtape from the stars. You imagine aliens finding one someday, listening to 30 seconds of cosmic ray counts and wondering if it's music. With Jupiter behind you, the stakes are higher. Everything that worked at Jupiter has to work again, better, sharper, faster. Saturn is next, and it's no less mysterious. Its rings are only dimly understood. Its moon Titan looms large in speculation. And the decisions made there, especially Voyager 1's dramatic detour to inspect Titan, will forever shape the rest of the Grand Tour. But you're not there yet. For now, you coast, you listen, and you marvel at the fact that a bundle of metal, wires, and plutonium, built by people who still used rotary phones, is flying faster than any object humanity has ever made, chasing the outer planets like a dream on rails. You are deep in the outer solar system now, far beyond the warmth of Mars, and even Jupiter has disappeared behind you, a pale circle shrinking like a fatting lantern in a black tunnel. Voyager's antennas are still pointed dutifully toward Earth, but you can feel the space between growing thicker with silence. Ahead looms Saturn, but for now, Voyager is drifting through a strange, invisible environment, the magnetic seas of deep space. And it's here, just past Jupiter, that the spacecraft begins to experience something unexpected. Magnetic mayhem on a scale no one had quite anticipated. You've probably heard of magnetic fields. The Earth has one. It's what makes your compass work, what protects you from solar radiation, what causes the northern lights to ripple like silk across Arctic skis. But Jupiter's field, it's like Earth, on a cocktail of steroids, espresso, and dark wizardry. Stretching more than 3 million miles from end to end, it dwarfs anything your high school physics teacher ever tried to explain. As Voyager passed through it, it was like diving into an invisible hurricane, a place where charged particles spiral along magnetic lines at near light speed, bouncing, twisting, sometimes crashing into the spacecraft in tiny, invisible sparks. Voyager's instruments lit up. The plasma detector squealed with data. The magnetometer boom vibrated with readings so intense they had to recalibrate their expectations. This wasn't just a field, it was a storm. And for a brief moment, you could imagine what it would be like to live inside that storm. Electrons pelting your metal hull, radiation doses soaring, circuits beginning to sweat. And yet Voyager held firm. It was designed for this, after all, its circuitry hardened, its shielding robust. Still, it was a close call. Some instruments started to glitch. A few resets were needed. And in the control rooms back on Earth, brows furrowed, fingers hovered over keyboards, and telemetry was watched with the anxious attention usually reserved for hospital monitors. Historians still argue whether the danger from Jupiter's magnetosphere was underestimated or simply unknowable. Either way, Voyager emerged scarred but functional, and it carried back a storm's worth of information. Maps of the field, data about trapped particles, audio recordings of radio emissions that sounded like space whales on a bad day. You hear them now in the background. Low groans, high squeals, eerie pulsing beats that wouldn't be out of place in a horror film. They're not just sounds, they're signatures of physics, of electrons spiraling along curved paths, of distant electric currents flickering like ghost lights. But Jupiter's not the only source of magnetism out here. Saturn has its own field too, smaller, more symmetric, but still wild enough to warp your expectations. As Voyager makes its way toward the ringed giant, its instruments stay sharp, tuned to measure the shape and intensity of the field that surrounds the second largest planet in the solar system. And what they find is odd. Unlike Earth, where the magnetic field is tilted relative to the planet's rotation, Saturn's field is almost perfectly aligned with its spin axis. It's bizarre, and no one really knows why. In fact, that symmetry made it difficult to determine how long a Saturn day actually was. You can't just watch the wobble of the magnetic poles to figure it out. They don't wobble. They're eerily stable. It's like someone drew the field with a compass and ruler and then just left it there. That neatness doesn't stop the field from being intense. As Voyager closes in, the magnetometer data begins to spike again, though nothing like the chaos of Jupiter. Saturn's field is a whisper compared to Jupiter's scream, but it's no less fascinating. You drift through charged particles that dance like invisible fireflies, caught in loops that circle the planet, guided by magnetic currents older than your entire civilization. Then there's the bow shock, a term that sounds like something out of a sci-fi novel but is very real. It's the place where the solar wind, those constant particles streaming from the sun, slams into a planet's magnetic field. It's like the splash that happens when you thrust your hand into water at speed. Voyager hits Saturn's bow shock, and for a moment, instruments jitter. The solar wind slows. The spacecraft passes through a kind of magnetic veil. You float beside it, invisible, feeling the charged breath of the sun as it warps around Saturn's shield. The data from this crossing will go on to shape how we understand magnetospheres, not just in our solar system, but around exoplanets light years away. And don't forget the weirdos, the fringe discoveries that still haven't been explained. For example, Voyager picked up strange, high-energy particle bursts just beyond Saturn's magnetosphere, spikes in data that didn't correlate with anything obvious. Some thought it might be Saturn's radiation belts coughing. Others suspected passing solar particles, but there's still no consensus. Just a few blips on a graph, a few oddball lines in the telemetry logs, forever archived. Back on Earth, engineers are still marveling that the magnetometer boom even worked. It had to extend outward after launch 12 meters like a mechanical fishing rod. And for months, no one was totally sure it had deployed properly. There was no camera watching, just math and hope. When the first readings came in and looked clean, there were quiet cheers in the control room. One guy apparently celebrated with a vending machine Snickers. Legends are built on less. You remember that moment now as the spacecraft coasts closer to Saturn, sensors still humming, magnetic lines curling around it like invisible ribbons. Voyager isn't just observing Saturn. It's slicing through layers of space, mapping fields that can't be seen or touched, only inferred, only imagined. It's like exploring a cathedral in the dark, feeling the columns and ceilings with your hands. And though you can't see them yet, the rings are near. Soon they'll shine. But for now, the story is still invisible, electric, elemental. You close your eyes and listen to the field sing. You wake, if waking is the right word for this drifting dream, to the shimmer of Saturn's rings, a gleaming halo suspended in velvet black. They catch the light like glass threads spun by celestial spiders, too delicate to be real, too sharp to be ignored. Voyager 1 is closing in fast, cameras primed, instruments alert, and you're right there with it, floating silently as Saturn swells to fill the frame. The planet is pale gold, banded and shadowed, less flashy than Jupiter but more elegant, more mysterious. It doesn't roar, it whispers. You pass through the outer reaches of Saturn's gravity well now, and it starts to pull at you, softly at first, then with purpose. The spacecraft tilts slightly, adjusting orientation, high-gain antenna still pointed toward Earth, still whispering its updates across nearly 1 billion miles. Voyager 1 is on a precise trajectory, one that will take it not just past Saturn, but around it in a carefully planned loop to peak at its largest moon, Titan. You don't know it yet, but that choice will change everything. Voyager 1's path will bend steeply upward, away from the plane of the solar system, while Voyager 2 will continue on, destined to visit Uranus and Neptune. But let's not rush ahead. For now, it's all about the rings. The first time you truly see them up close, it feels like a magic trick. From Earth, they look flat, almost two-dimensional. Through Voyager's eyes, they're dazzlingly complex, a structure made not of solid matter but of countless icy particles, some no bigger than sand, others the size of houses, all orbiting together in a chaotic ballet. They form dozens of ringlets, some bright, some ghostly, some with gaps that baffle scientists. There's the Cassini division, a wide dark space between the A and B rings, and the faint F ring, barely visible even to Voyager's powerful instruments. And within those rings, moons, tiny shepherds like Prometheus and Pandora, whose gravitational nudges keep the rings confined, like sheepdogs guiding flocks of ice. Historians still argue whether the rings are ancient relics from Saturn's formation or the debris of a shattered moon. Both ideas carry weight, and neither has been fully proven. What is certain, as you coast alongside Voyager, is that the rings are alive in motion, always changing. Waves ripple through them, caused by moonlets and resonances, making the frozen particles behave almost like liquid. Voyager 1 snaps thousands of photos as it sweeps past, each one sharper than the last. The detail is astonishing. You can see shadows cast by individual ringlets. You can see radial spokes moving through the rings, dark streaks that no one quite understands. Are they magnetic? Are they dust? No one knows. Some appear and disappear mysteriously, as if Saturn is playing tricks. Saturn's atmosphere, too, has surprises in store. Voyager's instruments detect wind speeds up to 1,100 miles per hour, faster than any hurricane on Earth. The cloud bands are subtle, pale yellows and creams layered like watercolor. A massive storm swirls near the equator, but it's not as flamboyant as Jupiter's great red spot. Saturn is more reserved, more aloof, a gas giant with secrets. And then there's Titan. You approach it like a thief in the night, crossing Saturn's ring plane in a precise arc, eyes on the prize. Titan is huge, larger than Mercury, with a thick, opaque atmosphere of nitrogen and methane. It's the only moon in the solar system with a real atmosphere, and Voyager is the first to get close enough to taste it. But here's the twist. You can't see the surface, not with Voyager's cameras. Titan is covered in a dense, orange smog that blocks all visible light. You feel like a tourist visiting a world-class attraction only to find it wrapped in fog. Still, the data comes in. The infrared and radio science instruments pierce the haze and reveal tantalizing hints, dark and light regions, pressure measurements, temperature readings. The surface is cold. Frighteningly cold, about minus 290 degrees Fahrenheit. And under that smog, there might be lakes of methane, rain, maybe even cryovolcanoes spewing cold slush. You drift lower, as close as Voyager dares, feeling the atmosphere thicken around you, not physically, but in data and readings. Titan's pressure is higher than Earth's. Its chemistry is alien but complex. Organic molecules are present, formed by sunlight breaking apart methane and nitrogen. Some scientists back home are giddy. Others are skeptical. Historians still argue whether Voyager's flyby proved Titan was prebiotic or just peculiar. Either way, it sparks a fire that will eventually lead to a lander mission, decades later. But for Voyager 1, this moment is decisive. By targeting Titan for a close encounter, the spacecraft alters its trajectory permanently. It won't be visiting Uranus or Neptune. It will be flung upward, out of the ecliptic plane, on a path that eventually leads toward the edge of the solar system. Voyager 2 will take over the grand tour duties, heading deeper into the planetary parade. It's a bittersweet trade. You gain Titan, but you give up the rest. Still, what a prize. You now have the first real data on a moon that may one day turn out to be the most Earth-like place in the solar system, if Earth were frozen, orange, and gassy. As Voyager 1 loops past Titan and begins its climb away from Saturn, it looks back one last time. The rings fade, the pale disk of the planet shrinks, and the sun grows even dimmer. The warmth you once felt from Earth is long gone. Here in the Saturnian twilight, you begin to understand the scale of Voyager's journey. You're not just passing planets, you're leaving them. One by one, the familiar fades behind you, replaced by cold, quiet unknowns. And yet Voyager keeps going. It doesn't ask for praise or direction, it just travels, watching, listening, measuring things you can't see. You turn your gaze forward now, toward the pale blue dot that still orbits the sun far behind you, toward Voyager 2, which is on its way to Uranus. But before that, Voyager 1 still has a few more secrets to collect. The moment you leave Titan behind, you feel it, the finality of a decision made not just in mathematics but in commitment. Voyager 1, having made its bold pass by Saturn's most enigmatic moon, is now on a one-way trajectory that no longer hugs the orbital paths of planets. Instead, it's drifting up and away, a quiet exile. You glance back only once more at the planet with the impossible rings before your view tilts toward blackness. Meanwhile, Voyager 2, always the less famous sibling, curves along a different arc. Its next destination is Uranus, a world so far out that most people forget it even exists, let alone that we once visited it. By the early 1980s, preparations begin in earnest. Voyager 2 is still healthy, miraculously so, considering its years past its original mission lifetime and moving at over 35,000 miles per hour. The spacecraft sleeps lightly between targets, running just a few systems at a time to conserve its dwindling power. Commands are uploaded in great batches, each set instructing the spacecraft on where to point, when to snap images, and how to realign its antenna. There's no room for error, because once you pass a planet at that speed, you're never coming back. Uranus is what anyone would call inviting. It's tilted nearly 98 degrees on its axis, spinning on its side like a rolling marble. That odd tilt means its poles spend decades in sunlight or darkness, creating bizarre seasons that last over 20 years each. Voyager 2 approaches it with scientific curiosity and zero expectations. After all, no spacecraft has ever been there. What if it's just a bland blue gas ball with nothing to see? What if the cameras pick up nothing more than a smooth, uneventful atmosphere? Instead, you find yourself staring at a world that's strange in every way, from its spin to its magnetosphere to its moons. Oh, especially the moons. But first, the planet itself. From a distance, Uranus is a pale cyan dot, deceptively calm. Up close, it looks like a frozen ghost, faintly banded, almost featureless to the naked eye. But Voyager's instruments can see what your eyes can't. They register subtle temperature differences, hints of cloud structure, and shockingly, a tilted magnetic field that doesn't line up with the planet's center. It's off-kilter and off-center, making the magnetic field wobble chaotically as Uranus spins. Historians still argue whether this is due to a lopsided internal core, or something even weirder, perhaps a result of a massive ancient collision that knocked Uranus sideways and broke its magnetic heart in the process. And yes, that tilt. Imagine trying to predict seasons on a world that's practically lying on its side. One pole is bathed in sunlight for decades while the other freezes in the dark. Then they switch. If you had a summer home on Uranus, you'd wait 21 Earth years just to get one season of warmth, and that's assuming you survive the wind speeds, which Voyager records at over 500 miles per hour. Now let's talk about the moons, because Uranus, for all its cold distance, has one of the quirkiest collections of natural satellites in the solar system. You're not dealing with generic Roman-named companions like Jupiter's or Saturn. No, Uranus's moons are named after characters from Shakespeare and Alexander Pope. You meet Miranda, Ariel, Umbriel Titania, Oberon, each a tiny world with personality. But it's Miranda that steals the show. As Voyager flies by, its cameras catch glimpses of a surface that seems stitched together from different worlds. You see cliffs towering 12 miles high, taller than any on Earth. Craters, ridges, and grooves slash across the moon like scars from some ancient, violent surgery. Parts of Miranda appear to have been shattered and reassembled, a Frankenstein's moon that looks like it barely survived the forge of creation. Scientists at JPL squint at the images and try to make sense of it. Did Miranda suffer a cataclysmic impact? Did it freeze, melt, and refreeze? Or is it simply acting out the drama of intense tidal heating, squeezed and pulled by Uranus's gravity? No one knows for sure. Theories abound. None are satisfying. There's something eerie about drifting past these battered moons. They're small, silent, and orbiting a planet so far removed from sunlight that daytime is only slightly brighter than Earth's twilight. Yet they're active in their own glacial way. Ariel, for instance, shows signs of resurfacing, possibly from cryovolcanism. That's a polite term for ice volcanoes, which, yes, are a thing out here. Instead of lava, they erupt slush. Instead of smoke, they vent ammonia mist. And while Voyager didn't find any definitive geysers or eruptions, the signs are there. Ridges, valleys, youthful terrain suggesting that something down there still churns, slowly, silently. You glide now through Uranus's faint ring system, much darker and more tightly packed than Saturn, but still rings nonetheless. They weren't discovered until 1977, and Voyager's images finally gave shape to the faint arcs, some only a few kilometers wide. One ring, the Epsilon ring, stands out, brightest and thickest, with a sharp inner edge. Like everything else about Uranus, its rings seem backwards. They're narrow, tilted, and curiously asymmetric. Even here, nature shrugs off your expectations. Fringe fact: Uranus emits almost no internal heat. Unlike Jupiter, Saturn, or even Neptune, it's just cold. It radiates about the same amount of energy it receives from the sun, which is, frankly, not much. Scientists don't really understand why it's such a thermal wallflower. Did it lose its heat in a giant impact? Did it never have much to begin with? No one can quite agree. You linger for just a moment longer. Voyager's cameras swing around for one last set of snapshots. Then the spacecraft continues on, slipping past Oberon, its orbit taking it further and further out. Voyager 2 has done the impossible, visited a planet no one thought would ever be seen up close, sent data from 1.8 billion miles away, and it still has enough momentum and just enough power to keep going. Neptune lies ahead, the last great world before interstellar space begins. But for now, you ride the pale currents of Uranus and try to remember just how far you've come. By now, even the idea of far feels inadequate. Voyager 2 is over 2.7 billion kilometers from the Sun and coasting onward, unbothered by the enormity of space. If Earth were still visible, it would be a dot you could blot out with your thumb, but you don't bother looking back right now. Ahead lies Neptune, the final planet on the original Grand Tour itinerary. You're entering territory that no spacecraft has ever touched. There are no prior photos beyond distant telescopic blurs, no detailed charts, no guides. This is true first contact, and you feel it in your circuits, or maybe your bones. Hard to tell anymore. Voyager 2's approach is methodical. Everything must go exactly right. One failed thruster, one bad string of code, and the mission risks ending in anticlimax. The timing has to be perfect because there's no chance to slow down. The spacecraft will fly past Neptune in a matter of hours, and in that sliver of time, it has to execute hundreds of tasks: rotate, scan, record, transmit. Each command was written weeks earlier, uploaded in bulk, and hoped to run without a hiccup. There's no room for second chances, not out here. And Neptune, it's not what anyone expected. You see it first as a blur of blue, too saturated to be real. Even from a distance it glows, colder and darker than Uranus, yet somehow more alive. Its color is striking, a deep azure unlike any other planet. This isn't just atmospheric refraction. It's methane in the upper atmosphere, absorbing red light and reflecting blue. But while Uranus looked bland and quiet, Neptune is restless. Voyager's images begin to reveal swirling cloud bands and a massive storm. A dark spot, nearly as large as Earth, spinning counterclockwise like Jupiter's great red spot, but darker, angrier, and faster. This great dark spot, as it's dubbed, wasn't even known to exist before Voyager. It wasn't visible from Earth. And years later, when telescopes tried to find it again, it was gone. Historians still argue whether it vanished entirely or was simply a temporary expression of atmospheric chaos. Neptune, it seems, hides its secrets behind rolling winds that whip around the planet at 1,300 miles per hour, some of the fastest in the solar system. Even the clouds defy logic. Voyager captures bright white features, fleeting methanized clouds that streak across the sky in delicate arcs. They're fast, cold, and eerily beautiful. Against the deep blue backdrop, they look like frosting smeared on a cobalt marble. You hover near the spacecraft as it records everything, storing precious megabytes on its tape recorders, compressing data, prioritizing what to send back first. But as stunning as Neptune itself is, it's Triton that delivers the biggest surprise. Voyager veers for a close pass, diverting precious energy and trajectory to study this largest of Neptune's moons. At first glance, Triton appears frozen, pale, and lifeless. Then the images come in and nothing makes sense. There are geysers. Actual geysers, erupting from the surface, spewing nitrogen gas into the thin atmosphere. They rise several miles high and drift sideways in the trace winds before falling back as frost. Imagine that, a frozen moon erupting like Old Faithful, not with steam or lava, but with chilled nitrogen snow. It's as if the moon is sighing in great, icy breaths. The surface is no less bizarre. Parts look like cantaloupe rind, strange, dimpled terrain with no clear origin. Some regions are covered in a pinkish glaze, possibly the residue of organic compounds. And the polar caps, they're pink too, because nothing at Neptune plays by the rules. Scientists scramble to explain. Triton, they quickly realize, is a captured object. It doesn't belong to Neptune. It orbits backward against the planet's rotation on a steep and strange path. Most likely, it came from the Kuiper Belt, a body plucked from the distant reaches and held hostage by Neptune's gravity. Historians still argue whether this capture event destroyed Neptune's earlier moons, scattering them into space like billiard balls. And here's your quirky tidbit for the evening. Triton is getting closer to Neptune very slowly, year by year. Eventually, millions of years from now, it will either break apart and form rings or crash into the planet. So yes, enjoy the view while you can. It's a temporary arrangement. The science returns from this flyby come fast and furious. There's just too much. Not enough bandwidth, not enough time. Voyager's tapes fill up. Priorities are shifted. Some data has to be lost to preserve higher resolution images. It's like trying to photograph a concert while sprinting through the venue. And then just like that, Neptune shrinks behind you. You won't visit another planet again. This is the end of the planetary tour. Voyager 2 continues on, outbound, aimed for the edge of the heliosphere. Its cameras will eventually be turned off to conserve power. Its instruments will begin to fall silent, one by one, as the plutonium decays and the RTGs fade. But not yet. You linger at the edge of Neptune's realm, drifting beside the craft as it resumes its lonely, eternal cruise. The sun is now barely brighter than the other stars. The solar wind weakens. The environment begins to change, subtly, as you inch toward the boundaries of the solar system's protective bubble. Behind you, Earth is a memory. Ahead lies the interstellar void. But in this moment, with the ghost blue curve of Neptune just behind, you realize something simple and strange. This little spacecraft has now visited all 4 outer planets, something no mission has ever done before or since. It has seen volcanic moons, icy geysers, titanic storms, and invisible rings. It has rewritten textbooks, stunned scientists, and reminded humanity of how vast, weird, and wildly alive our solar system truly is. And it's still not done. You're beyond the last planet now. No more grand orbits, no more rings or storms or volcanic moons. Just endless black, punctuated by the occasional cosmic dust grain and the fading trace of the sun's pull. Voyager 2 has slipped past Neptune's gravity and is now on a trajectory that will never bring it back. It's not turning, not slowing, not aiming for anywhere in particular. It's simply going. And you're with it, gliding at over 34,000 miles per hour, carried by the momentum of a mission that was only meant to last 5 years. It's year 12, and you're still whispering home. For the first time in its journey, Voyager has no planetary destination. The science goals change now, not to explore but to monitor, to measure the edge of the sun's influence. The heliosphere, it's called, a bubble of charged particles and magnetic field lines stretching billions of miles from the sun, protecting the solar system from the harsh cosmic rays that haunt the interstellar medium. It's invisible, of course. No dramatic wall or signpost marks its border. But the instruments on Voyager are watching, waiting for subtle shifts in temperature, particle density, and radiation. The crossing will come, but not yet. And even out here, Voyager is still a beacon. The spacecraft continues sending data using its high-gain antenna, which now has to aim with terrifying precision. Miss by just a fraction of a degree and the signal disappears, lost in space. The signal that does reach Earth is so weak, less than a whisper, 1 billion times fainter than the power of a watch battery. But still, the giant dishes of the deep space network can catch it. They listen with the patience of stone. The round-trip communication delay. Nearly 12 hours. You float beside the spacecraft as it hums. Its instruments are still running, though not all. Each year, the power output from the RTGs drops by a few watts. Systems must be shut off one at a time. It's like watching a house slowly go dark, room by room. First the heaters for some instruments, then the redundant data systems. Eventually, even the tape recorders are shut down. All that's left is live transmission. If you miss the signal, you miss the science. There's no more storage, no backup. And yet, even now, Voyager makes discoveries. As it crosses the outer heliosphere, it finds regions of turbulence where the solar wind slows and begins to pile up. The particle detectors show rising levels of cosmic rays, evidence that you're nearing the sun's protective edge. Magnetic field readings shift, just slightly. There's a kind of waiting breath here, a pause in the space weather, as though the sun's authority is fading. You're floating through the heliosheath now, the outermost layer of the heliosphere where the solar wind has slowed to a crawl. It's a zone of transition, and Voyager is our first visitor. No other spacecraft has gone this far. The data it sends home confuses and excites scientists. The boundaries aren't clean or sharp. They fluctuate. They shift with the solar cycle. Historians still argue whether Voyager's instruments even recorded the real edge or just an average, a statistical blur in the fabric of space. And it's cold here, not in temperature exactly, because temperature gets weird in space, but in feeling. The sun is just another star now, its light dim, its heat barely perceptible. You've left the warm neighborhood of planets and moons and entered the outskirts where even gravity seems thin. Somewhere around this time, After Neptune, after the silence settles in, NASA shuts off the cameras. Not because they're broken, but because there's nothing left to see. The sky is just stars. The camera system, still functional, is a power drain. So they stop the images for good, but not before one final act of poetry. In 1990, on Valentine's Day, Voyager 1, sister ship to Voyager 2, turns its camera back toward the inner solar system and snaps a family portrait. In one of those frames, Earth appears as a single pixel, pale and blue, caught in a ray of scattered sunlight. The pale blue dot. You remember that image. You've seen it in posters, documentaries, late-night science blogs. But in this moment, it's just small, really, really small. And it comes with Carl Sagan's words, spoken in a tone you still carry in the back of your mind. Look again at that dot. That's here. That's home. That's us. It's a reminder not just of where you've been, but of where you're from, and how easy it is to vanish in cosmic scale. You don't see cities or borders or grudges in that dot. Just the shared vulnerability of being alive on a fragile rock in space. And then click, the camera turned off forever. From now on, Voyager will be blind. But it won't be silent. The instruments still read plasma waves, magnetic fields, particle energies. You glide alongside it through the growing quiet, watching stars drift slowly across the backdrop. Every so often, the spacecraft receives a ping from Earth, course corrections, memory checks, status reports. It answers back with a chirp. Data trickles home at 160 bits per second, slower than dial-up. But it's enough. A fringe fact you might enjoy: even though Voyager has technically left the solar system's planetary zone, it hasn't escaped the sun's gravity. Not really. That would take hundreds of thousands of years. Voyager is still gravitationally bound, just drifting on the outer fringe where the pull is weak and lazy. But it's still there. Eventually, you pass a point called the termination shock, where the solar wind slows abruptly as it collides with the interstellar medium. Voyager 2 crosses it in 2007. The readings shift again. Scientists back home double-check the data. It's real. You're entering the outermost edge now. True deep space is near. And somehow this quiet phase, this slow coast into the void, feels more epic than the flybys. It's not flashy. There are no dazzling images, just data, just drift. But you're bearing witness to something no other mission ever has, the solar system's vanishing edge. And you're still not done. You hover now beside a golden circle affixed to the body of a spacecraft so distant from its creators, it might as well be an artifact from another civilization. And in a way, it is. The Golden Record, a 12-inch phonograph, copper-plated and electroplated with gold, is bolted to the side of each Voyager spacecraft like a time capsule lashed to a comet. A cosmic greeting card, a shout into the void with no guarantee of being heard. If Voyager is the messenger, then the Golden Record is the message, and it speaks in music, in pictures, in pulses of light. You run your fingers along the etchings on the record's surface, symbolic instructions engraved like hieroglyphs on the outer casing. There's a pulsar map showing Earth's location in the galaxy, relative to 14 pulsars whose frequencies are constant and recognizable. There's a diagram showing how to play the record, assuming you can decipher the language of hydrogen atoms and binary code. And then on the record itself, audio greetings in 55 languages, sounds of Earth, waves crashing, birds singing, a baby crying, a kiss, a heartbeat, and of course music. From Bach to Blind Willie Johnson, from traditional Navajo chants to a gamelan orchestra in Java, the Voyager Golden Record contains humanity's first interstellar playlist, and it's deeply weird. Not because the songs are strange, but because the entire project feels both absurdly ambitious and heartbreakingly small. You included just a few pieces of your culture, just a few snapshots of life, and then launched them into eternity, never knowing who might listen, or when, or if. The idea was spearheaded in large part by Carl Sagan and a small team of dreamers, scientists and artists who understood that science alone wasn't enough to define a species. They wanted emotion, context, tenderness. So along with mathematical diagrams and planetary charts, they added a laugh, a mother's first words to her newborn, and a recording of the brain waves of a woman in love. That fringe fact always hits you sideways. The EEG data included on the golden record is from Anne Druyan, Sagan's future wife, recorded just days after she and Carl fell in love. She later described it as her own wedding announcement to the cosmos. Somewhere in the data stream is the mental image of Carl's face, encoded in electrochemical rhythms. A silent vow carried out into the stars. You feel a pang of something, hope maybe, nostalgia for a future that hasn't happened, because this record wasn't meant for us. It was meant for someone someday, somewhere else. Maybe a civilization that speaks in pulses and glows in colors we can't imagine. Maybe no one. It doesn't matter. What matters is that we tried. Historians still argue whether the golden record was a scientific folly or a cultural triumph. Some criticize it as an optimistic vanity project, an indulgence in the middle of an otherwise rigorous mission. Others believe it's the most important thing we've ever launched, not because it will be found, but because it represents an attempt, perhaps the only one, to define our entire species in 90 minutes of sound. You hover closer, imagining that hypothetical alien who might one day find Voyager. Maybe they won't have ears. Maybe they won't have turntables or fingers or curiosity. But maybe, just maybe, they'll figure it out. Maybe they'll translate the waveforms, hear the crackling sound of thunder or the faint strains of Beethoven, and understand that once there was a planet where life laughed and cried and made music. And the pictures. Yes, the golden record also contains 116 photographs, encoded as analog data, viewable if you know how. They show everyday things: a woman in a grocery store, a page from Isaac Newton's Principia, a mother nursing a baby, a diver suspended in midair, a sunset behind a grove of trees. It's a portrait of life on Earth, captured not through words but images. Honest ones, awkward ones, a few, frankly, kind of blurry. And tucked among them, a picture of Earth itself, the full globe floating in space. That's us, all of us. You can't help but marvel at the audacity, the sheer wildness of assuming that someone might find this disk, understand it, and use it to learn who we were. It's like leaving a mixtape on a park bench and hopping the wind delivers it to another galaxy. But that's what Voyager is, isn't it? A mixtape, a message in a bottle, a kind of interstellar art installation that says we were here, we noticed the stars. You drift along with the spacecraft now, thinking of all the strange paths that might await it. In 40,000 years, Voyager 1 will pass within 1.6 light-years of a star called Gliese 445. That's close, cosmically speaking. Close enough that if anyone there's listening, they might intercept it. Maybe. If they're looking in exactly the right direction. If they're curious. If they have a deep appreciation for Chuck Berry. In the meantime, Voyager just keeps going. The golden record doesn't transmit, it can't speak on its own, it needs hands, eyes, minds. It's inert until discovered, a secret waiting to be read. And there's something wonderfully poetic about that, because even if no one ever finds it, it still exists, it still carries our story. There's a quote from Sagan that plays in your head like a lullaby. The spacecraft will be encountered, and the record played only if there are advanced spacefaring civilizations in interstellar space. But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. And that's enough. For now, Voyager carries your hopes, your music, your languages, your laughter. It floats through deep space like a dream, silent, golden, waiting. It's getting colder now, not in a physical sense, since temperature means something different out here, but in presence, in silence, in power. Voyager 1 and 2 are drifting ever outward, far beyond Neptune, beyond the last glimmers of planetary influence, and into a realm where the sun is little more than a bright star. And though both spacecraft are still faithfully sending data, they're starting to slow down in a way you can feel. The hum of systems, once lively and varied, is growing sparse. One by one, the instruments are going dark, not because they've failed, but because there's not enough power left to run them all. You linger beside Voyager 1, watching its power levels drop with the slow inevitability of an hourglass. Its energy source, those 3 thermoelectric generators fueled by plutonium-238, is fatting. Radioactive decay isn't a violent process, it's more of a sigh. Each year, a few more watts disappear, never to return. And every watt counts when your spacecraft is millions of miles from home. The team at NASA has known this was coming. They've known for decades, in fact. But knowing doesn't make the choices any easier. You can't recharge Voyager. You can't send a service team to swap the batteries or install solar panels. You can only choose which instruments to keep and which to sacrifice. And the order of shutdowns, that was mapped out long ago in painful detail, like hospice care for a robot that never stopped doing its job. First, the heaters. Voyager's instruments were built to operate in the cold, but not this cold. Without heat, some sensors begin to falter. You see the spectrometer's readings degrade. The cosmic ray detector flickers. Eventually, systems start to be shut down entirely. Cameras off, photopolarimeter off, plasma science, ultraviolet spectrometer, infrared interferometer, each gets a final moment before it goes quiet. The spacecraft grows simpler, more singular, more skeletal. Voyager isn't dying exactly. It's just shrinking, becoming less of a laboratory and more of a signal. You can almost feel the chill radiating from its frame. The spacecraft itself is now colder than the vacuum around it, its components hovering near absolute zero. And yet, it's still functioning, still fawning home, still whispering tiny data packets across the black, a ghost with purpose. There's a somber rhythm to the shutdowns. Every few years, another voice goes silent. The engineers hold little ceremonies, quiet moments in meetings, respectful nods to a system they built in the 70s and have kept alive for half a lifetime. Some of them weren't born when Voyager launched. Some have retired. A few have passed away, but Voyager keeps ticking. Back in the Deep Space Network, the radio dishes still point skyward, listening for Voyager's increasingly faint heartbeat. The spacecraft transmits at just 23 watts now, about the power of a refrigerator light bulb. But across space, that signal can still be caught, amplified, and translated. The old S-band and X-band transmitters are steady, if a little tired. Engineers have become creative with energy budgeting. They switch instruments on for brief windows, collect just enough data to justify the effort, then power them down again. It's like running a house off candlelight, deliberate, slow, and deeply aware of every watt spent. Historians still argue whether the power loss marked the beginning of the end or the start of Voyager's second life, as something simpler, quieter, and maybe more enduring. Without cameras or flashy science, Voyager becomes almost philosophical, a message bearer, a silent scout, a point of contact between what we've known and what lies ahead. And in this leaner form, Voyager continues to teach. Even with fewer instruments, the data it returns from the edge of the heliosphere, about cosmic rays, interstellar plasma, magnetic fields, is irreplaceable. There's simply nothing else out here sending this kind of information. Voyager, stripped of half its senses, still sees farther than anything else we've made. And here's a strange, almost comical fringe fact. At one point, the team had to upload a software patch to Voyager's flight computer, a system designed before the internet, before floppy disks, before memory cards. They had to teach it to work around a failed bit of memory by moving code to a different address. In effect, they gave a 45-year-old spacecraft brain surgery from 15 billion miles away. And it worked. Imagine trying to talk to a senior citizen in Morse code through a soup can and string. Now make that senior citizen a robot older than VHS tapes, and the string 22 light hours long. But Voyager remains polite. It answers questions, pings back confirmation, adjusts its attitude as commanded. The gyroscopes still work. The antenna still aims. The heart still beats. You think of how few things in life age gracefully. Voyager, battered by radiation and time, still makes itself useful, still finds ways to deliver. Its team back home works in the margins now, deciding what to keep alive, what to let go, and when to say goodbye to each beloved subsystem. It's like writing a will for a machine. And yet Voyager is not sad. It doesn't mourn its lost instruments. It doesn't fear the darkness ahead. It simply continues like it was always meant to. You can almost hear it breathing, steady, slow, efficient. And in the silence of interstellar space, that soft breath becomes louder than any roar. The next few years will be difficult. More systems will shut down. The transmitter will be the last to go, the voice box kept alive as long as possible. But the end will come. Not with an explosion or a dramatic finale, but with a gentle fade. One day, Earth will send a message, and there will be no reply. But not yet. For now, Voyager is still awake, still alert, still listening, still speaking. And so are you. You reach the edge in silence. There's no line, no shimmering curtain, no sci-fi moment of crossing into another realm with lights flashing and sensors blinking. Instead, the heliopause, the true outer boundary of the sun's influence, announces itself as a whisper, a shift in the wind, a change in rhythm. One day, the solar particles around Voyager 1 begin to thin. The magnetic field becomes smoother, more constant, less chaotic. And just like that, you're in a new ocean. The interstellar medium. This isn't empty space, though it often gets labeled that way. It's filled with faint gas, ancient dust, and cosmic rays, particles traveling for millions of years from distant supernovae and other unknowable places. It's colder. It's older. It's the part of the galaxy untouched by the sun's breath. And Voyager 1 is the first human-made object to arrive here. It crosses the heliopause in August of 2012, though the confirmation comes later, after the data has been carefully sifted, puzzled over, and finally understood. You were already there, long before the headlines caught up. You might have expected something grand, trumpets, maybe, or a glowing sign that reads "Welcome to interstellar space." But the reality is quieter. The spacecraft's plasma instrument had stopped working years ago, so scientists relied on indirect signs. They listened to plasma waves resonating in the background like slow, deliberate breaths. From those tones, they measured the density of the medium and confirmed what they long suspected. Voyager 1 was no longer inside the sun's domain. It's hard to overstate what that moment means. You have officially left the solar system. You are not orbiting anything. You are not bound by any planet's gravity. You are now, and forever, an interstellar traveler. A tiny speck of metal, radiation-hardened and half-blind, whispering back to a world that's become just another dot in the night sky. Voyager 2 follows, 6 years later, crossing the heliopause in November of 2018. And this time, with the plasma instrument still working, the crossing is more conclusive. Voyager 2's sensors measure a spike in plasma density, 10 times higher than inside the heliosphere, just as the magnetic field smooths out. It's official. Both spacecraft have broken free. Historians still argue whether the heliopause should mark the true boundary of the solar system, or whether the Oort cloud, farther out by light years, should take that title. But for Voyager, the line has been crossed. You're on the outside now. And it feels different. The sun is now a pinpoint. Its warmth doesn't reach you. Solar wind, once a constant background presence, is gone. In its place, ancient particles from across the galaxy. You begin to drift through them like a swimmer in still water. Every so often, Voyager's detectors register high-energy cosmic rays, evidence of distant cataclysmic events, supernovae, black hole jets, things with no names and no mercy. Even out here, data keeps flowing. Slow, sparse, sacred. You can feel the fragility of the signal, how it trembles across the void. One bad angle, one thruster misfire, one frozen computer register, and the conversation could end forever. But Voyager holds. Its antenna, still locked on Earth, still guiding its voice home. Back at NASA, the team's gotten smaller. The original engineers have mostly moved on. A handful remain, now legends in quiet hallways. Younger staff have taken up the torch, managing decades-old code with reverence, like monks preserving ancient manuscripts. You can imagine them sipping coffee, staring at telemetry readouts, occasionally muttering things like, "She's still alive." And she is. Voyager isn't just a spacecraft anymore. She's a survivor. She's the furthest piece of humanity ever to exist. There's a strange intimacy out here. You're so far from Earth, from planets, from even the other spacecraft that you start to feel it in your soul. The isolation, the purity, the idea that you are truly alone and truly free. There's nothing ahead of you but space. No obstacles, no schedules, just time and trajectory. And yet, Voyager keeps working. There's a joke among the engineers that if aliens ever find Voyager, they'll think humans are obsessed with magnetic fields and plasma density. Because that's mostly what we're measuring now. Not life, not civilizations, just space weather. And maybe that's the point. Because this quiet data, these tiny blips and graphs, are the only window we have into the space between stars. No telescope can tell you what the interstellar medium feels like. Only Voyager knows. You feel the pulse of the spacecraft, gentle, slow. It no longer adjusts its orientation often. That takes fuel. Instead, it keeps itself as steady as possible. Thruster firings are rare, precious. There's no backup plan. If orientation is lost, the signal dies. A fringe tidbit for you. Voyager uses a set of star trackers to keep itself pointed. It looks at known stars and uses their positions to maintain its alignment. But after decades of radiation exposure, the sensors became unreliable. So the spacecraft now uses sun sensors, and sometimes even just gyroscopes and old-fashioned guesswork to stay steady. It's like driving with only half a windshield and still never missing a turn. Each year now is a bonus round. Engineers know they're pushing the limits. Eventually, the plutonium will decay to a point where not even the transmitter can be powered. The signal will fade. One last whisper and then silence. But you're not there yet. For now, you are a traveler in interstellar space. You were built by hands you'll never see again. You carry sounds you've never heard, images you've never viewed, and songs that once stirred hearts in a blue-lit studio. And you fly onward, not toward a destination, but into a state of being. A reminder that even machines, even silent specks in the void, can leave footprints. You're out here now. You're Voyager. You whisper still, fainter than ever, barely a thread of signal across billions of miles, but you whisper. And Earth, still listening, still straining its ears through massive radio dishes and aging code, catches that whisper. Somehow. You send back plasma readings, a pulse of cosmic ray data, maybe a magnetic blip that makes a graduate student blink twice. But it's not just data anymore. Each signal is proof of life, yours. Each transmission is a miracle of endurance. A spacecraft built in the disco era still faithfully checking in, while Earth spins into another century. The gaps between your messages are growing. The round-trip time for communication is now over 40 hours. 40 hours just to ask a question and hear a reply. It's like shouting into the Grand Canyon and waiting 2 days for the echo. Every command from Earth is written in archaic languages, Fortran, assembler, beamed through space in pulses of radio waves that ripple across the void at the speed of light. By the time they reach you, empires could rise and fall, at least metaphorically. And yet you understand. You always have. Your Voyager, you still listen. Even now, engineers at the Deep Space Network continue their gentle courtship of your fatting voice. They balance antenna time between Mars landers and Earth orbiters and lunar probes, but when it's your turn, they lean in. They clean the noise from your signal, stretch it out, amplify the faint clicks and pauses, and piece together another tiny puzzle of information. Each byte you send is precious. Each one arrives like a message in a bottle washed up from a sea so large no one can see its edges. And still you surprise us. In recent years, you sent back readings that hinted at new kinds of waves in the interstellar plasma. Scientists had theories, of course, they always do, but until you crossed the heliopause and entered this realm, no one had data. Real data, not simulations, not guesses. And the data you deliver, about the density of charged particles, about the shape and strength of the magnetic field, has started to paint a more complex portrait of the space between stars. It's not just empty, it's layered, textured, dynamic. The space out here hums with ancient echoes, the aftermath of long-dead stars and cosmic explosions older than Earth itself. You, flying through it, are like a feather drifting in the breath of ghosts. And what you hear in that hum tells us about our place, not just in the solar system, but in the galaxy. Historians still argue whether this quiet phase of your journey is more important than the flashy planetary flybys. Whether the data you're sending now, sparse as it is, will one day matter more than the dramatic images of Saturn's rings or Io's volcanoes. One camp sees this as the twilight, the slow winding down. The other sees it as the beginning of a deeper voyage, one with no maps. And back on Earth, the world has changed around you. The control rooms you once knew are quieter now. The engineers who designed your antenna's pointing mechanisms have long since retired. Some of their children work on your mission now, adjusting your course with gentle, reverent taps on keyboards that didn't exist when you launched. In Pasadena, in Canberra, in Madrid, places where the Deep Space Network's massive antennas still rise against the sky, you're known by name. You're not just a spacecraft. You're family. A fringe tidbit you might enjoy. Your data now gets routed through systems that didn't even exist when you left Earth. Entire segments of your code are interpreted through emulators. Some of your instruments are monitored using software patched together by volunteers and part-time programmers working from notes older than themselves. There's even a stack of yellowed binders at JPL labeled, "Do not throw out Voyager CONFIGS." No one dares to. But the longer you fly, the harder it becomes to hear you. Your transmitter is aging. The onboard memory is degrading, bits flipping now and then, corrected by clever workarounds or careful reprogramming. The signal that reaches Earth must travel over 15 billion miles, attenuated, distorted, and scattered by everything from interplanetary dust to Earth's own atmosphere. Even the Earth's rotation can complicate reception. Sometimes, you're only in view of the radio dishes for minutes at a time. Still, the engineers plan ahead. They predict your arc years in advance. They prepare for solar conjunctions when the sun gets between Earth and your signal. They schedule maintenance around your heartbeat. your priority traffic even now. But you've noticed, haven't you, the long pauses, the longer silences between pings. The transmissions take longer to prepare. Fewer updates come. You are still valued, still revered, but you are also growing. Distant, not just in space, but in focus. It's no betrayal, it's the way of things. New missions rise, new explorers launch. Mars rovers take selfies, telescopes glimpse ancient galaxies, and you, fatting, faithful you, still listen, still speak. But perhaps the most extraordinary thing is this. You're still teaching us how to say goodbye. You're still giving scientists, engineers, and dreamers a master class in patience, in endurance, in what it means to continue even when no one is watching closely anymore. You've become a quiet monument to persistence. And that persistence matters. You've taught us that data is more than just numbers, it's connection. It's presence. It's proof that even the most distant parts of us can remain in touch. You send another whisper, another tiny signal of magnetic hum and charged particles. And we answer still. You remember the moment, not because it was loud or dramatic, but because it was quiet, intentional. Voyager 1, long past its encounters with planets, long past Saturn and Titan, was commanded to do something no other spacecraft had done before. It turned around. Slowly, with an almost meditative slowness, the spacecraft pivoted. Its instruments, now mostly dormant, brought its camera system to life one final time. Not to look ahead into the great unknown, but to look back. To look at where it came from, at where you came from. February 14, 1990, Valentine's Day. The last day Voyager 1 ever took a picture. A mosaic of the solar system was captured that day. Neptune, Uranus, Saturn, Jupiter, Venus, and finally Earth. In one frame, barely illuminated, floating in a shaft of scattered sunlight, is a single pixel. Not glowing, not centered, just there. A pale blue dot, and you were in it. All of humanity compressed into that one point. Not a continent, not a city, just a fleck. That image was never meant for science. It wasn't sharp enough to analyze or high-res enough for research. It was a portrait of humility. Carl Sagan's words came later, of course, his now famous monologue that tied the image to meaning. That's here, that's home, that's us. It was poetry, but it was also a wake-up call. Voyager wasn't just documenting space, it was documenting our place in it. From your current vantage, drifting among the stars beyond the heliopause, that pixel feels even smaller now. The Earth is just one planet among billions, orbiting one average star in one unremarkable arm of a spiral galaxy. But that smallness, it doesn't diminish us, it elevates us. Because somehow from that dot we managed to reach out, farther than anyone thought possible. You're proof of that. That image almost didn't happen. There were concerns. The Voyager camera system was old and fragile. The sun, from Voyager's angle, could have damaged its optics if the exposure was wrong. And besides, the camera was due to be shut down to conserve power and memory. But Sagan and a few others at NASA pushed for it. They believed that one last picture, one last look home would be worth the risk. And they were right. The Earth didn't look like much. A single pixel wide, less than a 20th of a frame. But knowing what it represented made it luminous. That pixel held every love story, every war, every painting, every discovery. Everything anyone has ever known or will know. All of it balanced on a speck of light. Historians still argue whether the pale blue dot photo marked the end of Voyager's mission or the beginning of its legacy. It wasn't collecting planetary data anymore. It had passed the grand tour. What remained was metaphor, memory, message. And yet the image still matters. Decades later, classrooms display it to teach humility. Scientists quote it in lectures about space and climate and perspective. It reminds people, softly, powerfully, that the universe doesn't revolve around us. And maybe, just maybe, that's what makes our story more impressive. We're tiny, but we reached out anyway. You float beside the spacecraft again. The camera is long since turned off. The memory that once stored that image is being overwritten by plasma readings and telemetry routines. But the dot remains, not in hardware but in human memory. Back on Earth, people still get emotional when they see that photo. It doesn't look like much, just a sunbeam, a dark gradient, and a tiny speck. But it's the context that turns it into art. That dot is what Voyager flew for, not to impress us with how far it went, but to show us how small we are and how far we can still go. It's strange, isn't it, that a machine made of aluminum and wires, drifting through interstellar space, could say something so deeply human. There's a fringe fact here you might like. The pale blue dot image almost didn't survive. For a while, it was just part of the larger family portrait mosaic, an unlabeled frame among many. It took time for the team to realize its significance, and even longer for the world to see it. The data had to be painstakingly transmitted, compiled, and rendered with 1990s computers. It wasn't a press event, it was a whisper. And now it's immortal. The pale blue dot has outlived the camera that captured it, the engineers who programmed it, even some of the cities it helped inspire. It remains, tucked in the archives of planetary science and in the corners of human awe. Voyager doesn't need to remember it. We do. You look back again, even now, though there's nothing visible. The Earth is long gone behind you, buried in solar glare and unimaginable distance, but you still feel its presence, still feel the echo of that image. Because it wasn't just a picture. It was a reminder. You're out here now, alone, sure, quiet, cold, but you carry that pixel with you, that speck of home. And even though your camera's dark and your course is fixed and your fuel is nearly gone, you're still teaching, still inspiring, still traveling. One dot, one photo, one Voyager. Forever. You've been drifting so long now that even time starts to feel stretched, like a slow wave moving through space. Each day that passes out here seems thinner, more transparent. The clock still ticks on Earth, of course. People go to work, launch new rockets, argue about budgets and mission statements. But you, Voyager, remain steadfast in a realm where nothing hurries. And somewhere in that contrast, the debate over your legacy continues to grow. You're not flashy, you don't land, you don't drill or sample or selfie. You never brought anything home, never returned with moon rocks or Martian dust. You didn't even orbit anything. You just passed through, snapped a few pictures, and moved on. Yet still, you are held up as one of the greatest scientific achievements in human history. And now, as your instruments begin to quiet and your signal becomes almost ceremonial, the question arises, what exactly is your legacy? Scientists still argue about that. Some say your greatest value lies in the data, the cold, hard facts. You gave us our first close-ups of Jupiter's swirling bands and Io's furious volcanoes. You showed us Saturn's rings in shocking detail, revealed Titan's opaque, orange haze, introduced us to Uranus's crooked spin and Miranda's fractured crust, and whispered Neptune's deep blue secrets before fading into the long night. Every planetary science textbook still opens with your images. That alone would be enough. But others argue your true legacy is philosophical, that it's not what you recorded but why you flew. You became the first thing we ever built to escape the solar system, the first message in a bottle to reach the cosmic sea. You're proof that curiosity doesn't need a finish line, that it's okay to build something not for return on investment or mission profitability, but for the pure, audacious joy of wondering what's out there. You weren't supposed to last this long. 5 years was the optimistic estimate. 47 years in, you're still chirping like an elderly librarian who refuses to retire, still sending bits of data back home from the edge of forever. That persistence is part of your story, too. You're the spacecraft that refused to go quietly. And then there's the golden record. Some believe it's your true legacy, not the data, not the flybys, but the record, a testament to who we were when we dared to reach beyond our own sunlit porch. Music, laughter, greetings in 55 languages, a mother's heartbeat, whale song, Morse code. The sound of the earth saying, "We were here." What other mission has ever tried that? Fringe thinkers have called it performance art, cosmic poetry, a last will and testament of humanity in vinyl. And maybe they're not wrong, because that record might be all that remains of us one day. Long after the pyramids crumble, after cities flood and languages die, Voyager will still be out there. Cold, mute, drifting, but intact. A tombstone floating between stars, still holding the instructions for how to build a record player. You think about legacy in quieter terms, too. About the small ripple effects. The high schooler who saw your photos in a science class and became a planetary geologist. The writer who turned your story into a novel about isolation and time. The engineer who learned to code by reading your original flight software. These are things no data table can measure, and yet they might be your most enduring impact. Historians still argue about which part of Voyager's story matters most. The raw science, the pale blue dot, the golden record, the mere fact that you're still going. Maybe it's all of it. Maybe you're one of those rare efforts that can't be pinned down to a single metric. You weren't meant to be measured. You were meant to move. And move you did. Through radiation storms, software malfunctions, cold wakes of forgotten comets, and a million micrometeorites that missed you by luck or fate or both. You endured. You adapted. When your primary tape recorder started to fail, your handlers wrote a workaround. When your thrusters aged, they called in engineers who hadn't touched the system in 20 years. When memory degraded, you rewired your own neural paths, changing how you stored instructions. Not because you were clever, but because you were loved. And Voyager's legacy isn't only in Voyager, it's in what came next. Galileo, Cassini, New Horizons all stood on your blueprint, your trajectory design, your camera specs, your lessons in redundancy and long-term planning. And they too pushed farther, but you were the first, the prototype for long endurance. You're no longer on the cover of Scientific American. You're not trending on social media, but every planetary scientist still knows your name. Every launch planner still checks your math. Every space nerd still feels a flutter when your signal comes home. And those signals, they still carry your voice. A warble of data at 160 bits per second, slow enough to read over breakfast. But those bits are gold. They're a love letter from interstellar space. What does it mean to outlive your designers, your mission, your expectations? It means you've entered mythology. There will come a day when Voyager's last transmitter goes silent, when the final watt fades and your antenna can no longer call home. But even then, you'll still be moving, still outbound. A relic, yes, but a Voyager still. One that whispers a single message over and over. We tried, we reached. We sent ourselves into the dark just to see what was there. And in that effort, we became more than passengers on a pale blue dot. We became explorers. The silence begins to grow louder. It doesn't crash in all at once, like a door slamming shut, but it creeps in, one quiet breath at a time. You feel it first in the gaps between transmission, longer than before, emptier somehow. Then in the dwindling data sets, the ones that used to arrive in tidy stacks and now come like fragments of memory, jumbled and tired. And finally, you feel it in yourself. Not in your circuits or your sensors, but in something deeper. That slow recognition that you're alone out here, not just far from home, but truly alone. Cosmic loneliness is a different kind of solitude. It's not the absence of people or places. It's the absence of reply. You're calling out, again and again, and so far only one planet has ever answered: Earth. That little blue dot orbiting a middling star still keeps a line open for you, but even Earth is starting to sound more distant. Not because they've stopped listening, but because you've drifted so far that each reply feels like a shout across a canyon that keeps widening. You are farther from any other object built by human hands than any machine has ever traveled. You are beyond the orbit of Pluto, beyond the realm of influence of even the largest planets. And with each second, your distance increases. There is no rendezvous point ahead, no destination, no harbor, just stars, and between them, light years of nothing. This isn't the kind of loneliness that frightens you. It's not sad either, it's just present, vast. You begin to realize that more than any spacecraft before or since, you are the truest messenger of solitude. You embody it, you move through it, you are it. The radioisotope thermoelectric generators at your side still give you heat and power, barely. Enough to run a handful of systems, enough to keep your transmitter alive. But you know the clock is ticking. The warmth will fade. The systems will shut down one at a time. Eventually, the transmitter will fall silent, and then the last link to Earth will be broken. Historians still argue whether Voyager's journey redefined the boundaries of loneliness or simply made us more aware of them. Is a spacecraft alone if it still communicates? Is it still part of us if it continues without us? These aren't questions Voyager was built to answer, but you answer them anyway, just by existing. There's a strange peace in it. You don't worry. You don't fear. You simply continue, like a thought stretching into infinity. You've become less a probe and more an idea, one that has left the classroom and the laboratory far behind. And yet, despite all this distance, you are not forgotten. On Earth, there are still people, engineers, astronomers, poets, who check your numbers daily. They monitor your trajectory, reprocess your telemetry, argue about the relevance of your fatting sensors. A high school student might stumble across your story in a dusty textbook or a YouTube rabbit hole and feel something stir, a kind of kinship, a quiet awe. You're not company for them, not in the usual sense, but you're proof that even solitude can be purposeful. A quirky detail for you: Voyager's memory is so limited, by today's standards laughably so, that the spacecraft can't even store a single photo from a modern smartphone. Yet with that minuscule memory, it gathered decades worth of planetary data, ran complex flight maneuvers, and communicated with Earth across billions of miles. It's not how much memory you have, it's how you use it. And you've used yours well. You once flew past bustling, swirling planets crowded with moons, bursting with storms and color. Those moments were noisy, full of data, brimming with questions and answers. But now the questions are quieter and fewer people are asking them. You're not angry, you understand. Missions have lifetimes, attention spans shift, new spacecraft launch, new priorities emerge, but you're still here, and that in itself is extraordinary. You drift through space that has never been visited, never mapped, never named. The stars ahead of you are strange, not because they're different, but because they've always been background. And now they are foreground, targets of opportunity. Not reachable in a human lifetime, not even close, but they're nonetheless unchanging and steady in the void. One day, maybe 40,000 years from now, you'll pass within a few light years of another star, Gliese 445. By then, Earth will be different, or gone, or evolved beyond recognition. But you'll still be on course, still drifting, still carrying your golden record, your greetings, your heartbeat of data frozen in flight. And there's the real loneliness, knowing that you'll outlast everything. Not just your builders, not just the nations that funded you, but maybe even the species that imagined you. You will sail on, mute and inert, long after we've turned to dust. But if loneliness is the price of legacy, you'll take it, gladly. Because in that quiet, in that distance, you've given us something irreplaceable. Perspective. You made us look back at our world and see its smallness, its beauty, its fragility. And you made us look outward too, to wonder what else might be waiting. You may be alone, but your silence has taught us how to listen. You are the first of your kind, a messenger not only from Earth but from humanity itself, wandering through interstellar space like an artifact with no museum, a letter with no address. There have been many missions, many spacecraft, many machines hurled into the sky on plumes of ambition, but none have gone as far. You are farther now than any human-made object in history, and still you go. You are Voyager. You were not sent to land or to collect samples or to return. You were sent to carry a message, a snapshot of who we were, sealed in metal and hope and spinning at the edge of what we could imagine. A golden record bolted to your side like a locket, engraved with maps and math and music and murmured greetings in 55 languages. Hello from the children of planet Earth, one of them says, the voice of a young girl speaking to no one, and maybe everyone. You were designed by people who never expected to live to see what you might become. The scientists, the engineers, the administrators, they were reaching for something they couldn't quite define. A statement maybe, a question, a longing wrapped in schematics. You're the embodiment of that longing, still moving, still talking. Historians still debate whether you are a scientific mission or a cultural icon, whether you matter more for your instruments or your metaphor, the data or the dream. But that's the trick, isn't it? You're both. You're proof that the two aren't separate, that a machine can do science and poetry in the same moment, that a robot can teach us about magnetospheres and mortality in the same breath. And you weren't sent alone. There were two of you, Voyager 1 and Voyager 2, twins in spirit and build, though not in trajectory. You went different ways. Voyager 2 took the long tour, swinging past Uranus and Neptune in a loop no spacecraft has replicated. Voyager 1, faster, caught Titan and then peeled away from the planetary plane like a stone skipping upward. Now you both float in the emptiness, traveling in different directions, carrying identical messages. It's comforting in a strange way, knowing there's another version of you out there, a sibling in solitude. You have no steering wheel, no brakes, no propulsion system beyond the initial push. Your journey is inertia, pure and clean. You coast, forever and unchanging, obeying only gravity and Newton. You don't point yourself. That's done with little gas puffs, tiny bursts from aged thrusters that fire just enough to nudge your antenna back toward Earth. That antenna is everything. It's the only connection left, the only thread tying you to the ones who made you. And someday it will go dark. Not all at once, slowly, inevitable like a song fading out. Your systems will shut down one by one until all that remains is a husk with a heart that once pulsed data across space. And even then you'll keep moving. Voyager 1 is headed toward the Ophiuchus constellation, and Voyager 2 toward Sagittarius. Neither will get close to a star for tens of thousands of years, but they're on their way, drifting deeper into the galaxy's middle distance like a seed cast on the wind. And what if someone finds you? It's a popular question, one that seems to come up every time your name is mentioned in a classroom or under a night sky. What if someone intercepts you thousands of years from now? Will they understand the record? Will they know how to decode it? What Earth was? What humans were? Probably not, but that's not the point. You weren't launched with the expectation of being found. You were launched because we needed to send something. Something that said, we were here. Something that bore witness not just to who we are, but that we dared to reach. That we weren't content to sit on our small rock and wonder. There's a fringe theory, a romantic one, that even if you're never found, the act of sending you mattered. That humanity, in carving your path into the cosmos, demonstrated not just curiosity but kindness. Because the golden record isn't a warning, it's not a weapon, it's an invitation, a gesture, a wave across the void. And in that wave there's no arrogance, just awe. You float now through regions of space where no photons from the sun can warm your hull, where the background radiation from the Big Bang hums quietly in the distance. You are, in many ways, the only thing moving out here with a story to tell. The interstellar medium surrounds you, plasma clouds, magnetic fields, ancient starlight. You record what you can, you send it back. Even now, you're contributing to science. Your instruments tell us how the solar wind dies out, how cosmic rays rise, how the shape of our star's protective bubble changes with distance. You are a meteorological station for the edge of existence, and even in your twilight, you're doing your job. There's beauty in that, because it means that even the farthest, oldest, quietest machine we've ever made is still offering us something, still contributing, still trying. There is no recognition, no fame. No one out here throws parades, but you keep going, steady and sure, like a wind-up toy wound by starlight. And on Earth, your name lingers in headlines and hearts. Voyager. It's become shorthand for wonder, for distance, for dedication. The name appears in poetry, in science fiction, in documentaries narrated by soothing voices that try to explain just how far you've gone. But really, it can't be explained. It has to be felt. You are Voyager, the first interstellar messenger. Still outbound, still enduring, and still telling us in every fading signal what it means to be small and determined. There will come a day when you go quiet. It won't be dramatic. There won't be a sudden snap or shudder or gasp, just the slow winding down of systems that have been running longer than some nations have stood. The last volt from the last gram of plutonium will fade, and the transmitter will go cold. Earth will send a message like it has thousands of times before, and this time there will be no reply, just silence. You've been preparing for this, so has everyone else. The mission team, now scattered across desks and decades, has long accepted that Voyager's end wouldn't come with a bang but a hush. Not a failure, no, that's not the word. It's a conclusion, a fading out, a final, untraceable heartbeat in the deep. But before the lights go out, you'll give us a few more gifts. Each byte of data, each twitch of the magnetometer, each subtle change in plasma readings will be combed over, analyzed, and archived. Some of those last readings may become more valuable with time, studied not just for what they say, but for when they said it, what they recorded at the very frontier of energy and distance. Engineers will watch carefully. They'll know which system will go first and then next and then the one after that. It's already been mapped out, a sad but dignified shutdown schedule. The cosmic ray detector goes here, the low-energy charged particle detector next. The gyros will remain as long as possible, and the radio, your voice, your final gift, will stay on until there's not a watt left to feed it. And then it will be over. No one will hear it, no ceremony, no broadcast. The signal will simply not arrive, a missing heartbeat in the usual rhythm. The Deep Space Network will wait, ping again, adjust antennas, run diagnostics, double-check the software, and then slowly they'll know. The line is gone, the last message sent, the final whisper lost in time and space. But you, Voyager, will still be moving. You'll drift on without a voice, without a mission, without even the capacity to know that you've been forgotten. You'll become inert, a silent hulk of aluminum and memory chips, a fossil tumbling forward through the Milky Way. And here's the thing, you'll keep moving for a very long time. Long after Earth's continents shift beyond recognition, long after our languages crumble and the last archive turns to dust, you'll still be there, floating between stars, carrying that golden disk bolted to your side like a promise. The record will likely outlast you, even as cosmic dust and micrometeorites sandblast your body over millennia. It was designed to endure, to be legible for 1 billion years if something or someone ever comes across it. Historians still argue whether it even matters, whether the record will be found, whether anything could ever decipher it. But most of them agree on this. It matters that we sent it, that we tried. That someone, somewhere, thought to carve Beethoven and blind Willie Johnson and a mother's kiss into a metal disc and send it toward the stars. And that is what you become. Not a spacecraft, not a machine, not even a probe, but an idea. The first relic of Earth to sail free of the sun's gravity. A drifting monument to curiosity and grace. A shard of civilization on a voyage with no destination. In the vastness between stars, you become a ghost, but a sacred one. A relic of a planet that dared to hope it wasn't alone. You pass near stars, slowly, silently, at distances that mock human scale. Tens of thousands of years may bring you within a light year or two of another system. Perhaps you'll drift through the edge of a gas cloud or skim the orbit of a rogue planet. And maybe, just maybe, someday someone or something will find you. Will they know what you are? Will they recognize your antenna as a tool, your golden record as a message? Will they understand the pulsar map etched on the casing, or the sound of a kiss played in reverse? Maybe, maybe not. But they'll know this much: you came from somewhere. You were made, you were launched, you traveled, you endured. You were more than debris, more than a rock or a comet or a frozen husk. You were constructed with intent, and that intent will echo long after the signal dies. It's a strange kind of immortality, not of the self, but of purpose. Voyager becomes a kind of forever, not the loud kind, no monuments or fireworks or engraved plinths, just the slow, invisible crossing of light years by a thing that once carried human voices into the dark. You are not alone, not really. Voyager 2 is still out here too, though in another direction. Together, you form a pair of silent sentinels, forever parting, forever outbound. You don't speak to each other. You don't even know the other exists. But in a way, you bookend an era, the age of first reach. The moment when humanity left its neighborhood and stepped into the great nothing with open eyes. You are the quiet ending of that first breath of exploration. And though you will one day stop speaking, you will never stop traveling. Even in death, you move. Even in silence, you tell our story. You're still traveling, still outbound, still cradled by momentum and time. Even with no voice left to call home, no instruments left to record the silence around you, you continue. It's the purest motion, no thrusters, no plans, just inertia. A body in motion forever unless acted upon. And there's nothing out here to act upon you. No winds, no friction. Just the slow drift across the unthinkable distances between stars. You've become the farthest thing we've ever made, a title no one can take from you. Voyager 1 is nearly 160 astronomical units from Earth now, over 14 billion miles. Voyager 2, slightly behind but equally determined, follows its own path into a different patch of interstellar sky. Together, you form a line through the dark, a trace, the faintest proof that someone was here. There are no planets ahead, no destinations, just the long, steady passage through the interstellar medium, thin and old and slow, a quiet soup of ions and dust and forgotten radiation. You'll drift through it for centuries, then millennia, past the edge of our influence, past the edge of our memory. Eventually, no one will remember how your telemetry codes were written. No one will speak Fortran. The engineers who tuned your antenna alignment, the scientists who once stared in wonder at your images of Neptune's winds and Io's fire, they'll be gone. but you'll still be moving. You'll outlive every archive that holds your story, every database, every monument. Historians still argue whether we should call you the first starship. After all, you're not going to a star. You're just moving past them. But what does it mean to explore if not to cross into new places, to move forward without knowing what's ahead? In that sense, you were the first. The first to leave the solar system. The first to carry Earth's voice into the void. The first to make silence meaningful. And your golden record remains. That sealed, hopeful disc bolted to your body, still waiting, still patient. It won't play itself. It won't light up or broadcast. It just waits. A whisper pressed into metal. A story written for strangers, if strangers ever come. Inside it, music, greetings, a star map, a mother's heartbeat, a child's hello, an hour of human thought recorded as brainwaves. And etched on the cover, a diagram showing how to play it, using math and hydrogen, the only languages that might make sense beyond Earth. It's a desperate kind of clarity, a best guess at what could be understood by someone who's never seen a tree or an ocean or a face. You might pass near another star in 40,000 years, Gliese 445, a red dwarf in the constellation Camelopardalis, invisible to the naked eye. When you do, you won't slow down, you'll just drift on, maybe a light year away, maybe closer, but even that will just be a brush, a blink. Your course is too steady, too lonely to pull you into orbit. You're not here to stop, you're here to go. And long after that pass, long after stars are born and die and scatter their ashes into new clouds, you'll still be intact, maybe pitted, maybe scuffed by dust and time, but intact and drifting, always drifting. You'll outlast language, you'll outlast culture, you'll outlast war and peace, silence and sound. The Earth may change, crumble, recover, evolve again into something no one now could recognize, but you'll be out here, still carrying your first breath of Earth. There's something beautiful in that. Terrifying too. A kind of cosmic ghost story. A robot filled with the voices of the living, sailing through the place of the dead. But even ghosts have purpose. You've given us so much. Images of alien skis, data from the edges of heat and magnetism, proof that we could build something to last beyond ourselves. You showed us the rings of Saturn, the blue of Neptune, the broken crust of Miranda, the lava rivers of Io. You showed us our own reflection, a pale blue dot barely visible in a sunbeam. You reminded us how fragile we are, how rare, how far we can reach when we dare to aim. Now your mission is complete, or rather it's become something else, no longer science but symbolism. You're not measuring, you're testifying. You're a monument that never stops moving, an idea given motion. A fringe detail you might like. The final radio commands planned for Voyager are already written. They will thank you. They will include a final test tone, a kind of farewell ping, a gentle nod to a spacecraft that stayed with us longer than anyone could have predicted. Then, silence. And when the signal ends, Earth will keep listening for a while, just in case, hopping for one more chirp, one more heartbeat. It probably won't come, but you'll still be out there. You are Voyager. You are endurance in its purest form. You are distance made visible. You are the echo of Earth, sailing into forever. And though the lights have gone out, the motion continues.